my programming engineers. Welcome back once more to this drives course. And today we're going to analyze our errors, our flaws, our failures, and our alarms, and how to fix them. Because it's something that is fundamental in everything that has to do with drives. Why? Generally, we already configured our drive, we connected it, we started our device, we already have our application ready, it's under control and everything, yes? So our boss already gave us a congratulations, a pat on the back and everything, right? So we already got an A. However, it just so happens that there is an external issue or topic, things that we can't control, different variables that might affect our process, or in this case, might affect our drive. So therefore, when we get these types of failures and these alarms, that's when they call us, and that's when they tell us, so what's wrong with our system? What does our application have and how can I solve this? Because if we know how to diagnose correctly all of our failures and all of our flaws, we could very well make our line more efficient. Especially if there's an alarm or a failure and we know how to identify it. Then that way the line is not going to be down as long as we would expect. Because the company then has an incredible engineer that has taken this course that know how to solve these issues. Okay? So if they call us and the line is down, and we know that it's probably the motor that's down, then the first thing that we're going to do is to open our cabinet in case there's no communication, because if there is communication, then that's why the HMI alarms are for, which we previously have had to add connected. So we open the cabinet and we notice that there's codes. What types of codes, you ask? For failures or alarms. So these types of codes are used to identify them so that we know really what was the last clue, what happened, and how to solve it. Now, I'm going to solve this, or we're going to solve this, with the help of my manual. For example, Alan Bradley, specifically for PowerFlex, decided not to add any alarms. So that's where they say, they might have some messages, but they decided not to add any alarms. Now, this is also very strange because the HMI parts send out alarms or failures. But no, we only have failures. Now, what's the difference here? Failures is something physical that happened at the moment with the drive. Okay, something that was affected with our drive, something external, or something that could have damaged our variator. And generally, our code starts with an F. F for faults or failure. Okay, now what are alarms? These are warnings. These are alerts that our drive gives us in case something happens if we continue running that action. Or it sends out a warning simply saying that there's going to be an imminent danger if we continue doing certain activity or certain action. Okay? So faults has to do with something physical. Alarms are warnings. So flaw, something already happened. The alarm is triggered when something is about to happen, but I'm giving you a warning. That's what the drive is saying. Okay? Now, how do we look for these alarms? Well, first off, let's do one thing. I have here my emulator or my simulator, and we are going to force our drive to show us an alarm. Okay, so I'm going to power on my drive, and remember that physically it's exactly the same thing. Okay, so therefore, what's the alarm that I may have or that I might have? This one. So I'm going to remove the hardwired base block, which, remember, it's like my emergency stop in my safety device. This is set as regularly closed, and what did I do now? I simply opened the circuit, and it calls out for an alarm. So it's telling me that something happened, okay? It's giving me a warning, or that something important is about to happen. Okay, beware. That's what it's saying. Okay. So if I do this again and I connect it again, it clears out the alarm. Now there's certain situations where the alarm is wiped off with our reset button. The failure or the fault is exactly the same thing, but remember, there's something that's happening. And it's going to continue happening as long as there's still that fault. Okay. So when we wipe out any alarm or any warning, is when I can continue working normally. Okay. So if I reset it here, it's not going to listen to one thing I say or I ask it to do, because it's still not in the disconnection part. So the advantage here is that I add it here, I eliminate it here, and I can connect it again. But it doesn't happen the same for the rest of the alarms. So we have to wipe it off. For example, it says here, all right, so I'm sending the HBB code. All right, now let's look for this. We generally have a alarms and faults section. And they're generally right at the bottom. Here, actually, the drive is divided here as drive alarms, faults, and errors. Now, this is saying what each thing is. So we have minor faults, which are you still can do something about it, and at the same time, they added the alarms. For operation errors, whenever there's a conflict in our parameters. So if I overexceed a limit, it's going to tell my alarm, hey, you're going over. There's nothing else that I can do here. So tuning errors, this is only when we interrupt our tuning. And here, this is where I get all of my alarms, depending on my drive. For example, here I got HBB, sorry. So it's saying here, HBB, safe disable signal input. As easy as that. And then it says, so go to page number 285 for more information. So a drive is not only about getting a fault, but it's also showing us available solutions for all the alarms for all faults. So this means that if we don't want to solve something, it's because we don't want to solve it. Okay? It's not about something that cannot be done, but it's about that we don't want to check what it is. So if it's something that is damaged, then that's something different. But at least we have the information on what it is. So it's giving us the same option. Digital input for the safe disable input channel is open. Okay, because this is regularly closed. That's why we have our bypass. Okay, so possible solution. Well, first it says here, cause there's no signal in our H1 terminal. So check if external safety circuit tripped and disabled the drive. If safe disable function is not utilized, check if the terminals HC, H1, and H2 are linked. So maybe this one or this one is damaged, and that's why it opened the circuit. Now, what happens if internally these terminals are already open? Because probably here we have our continuity, as well as for our cables, and also for our emergency stop. But what do we do internally? In this case, our solution tells us to replace the drive. Okay, there's nothing independent that replaces this. You either replace the drive or you have nothing. So therefore, we can start checking and reviewing our code. If we have our code here, EF2, then what's going to happen here? If we have our code LT2, what is going on? What's happening? If our code shows us the OH, what are we going to do then? So this is a scope that we add for our L802, so then we have to change our parameter. Or maybe for our cost, says your radiator temperature is too high. Check your surrounding temperature. Or improve quality of the circuit airflow. So in other words, install a fan to improve temperature, improve the air circulation with the enclosure panel. So in this case, this is about the reduced spaces. If it's more reduced, it's going to heat up. Or install a fan, external fan from our drive. That's also an option. I mean, we can also add an external air conditioner on the surrounding area. And also it says, remove anything near that may cause extra heat. Okay, and then it says here, so another probable cause. Our internal fan stopped. And if it stopped, internal cooling fan is stopped, and this is the minor fault name. After replacing the fan, reset the cooling fan maintenance parameter to 0 so that it starts again. And then it says here, airflow around the drive is restricted. Well, here's the space between the drive as referred to by the manual, which is the allowed space between drives or devices. So provide proper installation space around the drive as indicated in the manual. Refer to control panel. And then it says, this is another solution. Do you see how many solutions we have? Okay. So this is what having an alarm helps us for. Okay. Actually, this is a fault. So alarm detection, this is a minor alarm. So another solution, for example, says, check for dust or foreign material clogging the cooling fan. And then it also says, clear debris caught in the fan that restricts airflow. So these are the possible causes and solutions. So anything that we have in our drive, everything is documented in our manual. So many times we see that our line is stopped and we don't know how to start it. Remember that we can do troubleshooting, and we put on our detective coat. We do our Sherlock Holmes work. We investigate. And so therefore, we should be able to investigate what the possible causes are. If it's stopped, then open drive and see if there's an alarm triggered. If there is no alarm triggered, or if there's no fault, any sort of code, then in that case, something caused it to stop. There's some signal, some sort of signal. Maybe there's the switch is at fault, or someone pressed the stop button, or something happened in our PLC that communicates to our drive. Okay, but if there's no alarm, something stopped it, definitely. If there is an alarm or a fault, then we need to investigate again through our manual. Okay, PowerFlex. Now that I have everything open here, I'm going to open it again. And remember, guys, almost at the last part, we have our alarms and faults. If not, we're going to look for it like this. Faults. Let's see here. Here we go. This is the fault and diagnostic groups. But mostly it's on this side. Okay. This is what tells us what our LEDs are all about, what they mean, etc. This is how we're going to, they're going to show in Allen Bradley. Okay. And here we have our faults. Same thing. Our fault and our action. If there's no fault, there's nothing we can do. Lost, power loss. A description is single phase operation detected with excessive load. So then what am I going to do? I'm going to monitor my voltage or my feed, and let's see where this was interrupted. So we're going to analyze and measure our faults between our phases, with our multimeter. And if there's none, then we just lighten the load. Okay, so under voltage. Under voltage monitors the feed through a lower voltage. Now, over voltage monitors the line feed exceeded, or the DC bus voltage exceeded max value, or also caused by motor. Okay, so the bus, if the bus has over voltage, can also be caused by motor regeneration, which is what I was saying. One of two things either happened. Or, sorry, we can do either one of two things. We add a brake so that we can eliminate that excess energy, or we add a more extended brake lapse. Oh, actually here. Or we install a dynamic brake option. Okay, so we can solve everything thanks to our failures, our faults, and our alarms. So depending on what you all have, you have your manual for that drive. Remember that they're not all the same. So they each have their own code. And we are going to look for our fault and our alarm, and we see what is actually happening and how to solve this. Okay, so this is a huge clue, and that's where we can act on it. Okay? So, having said this, we're done with our topic, and we're going to move on to our next class. Thank you very much, guys, for your attention.